when we have to stop. We have to get CO2 out of the atmosphere now. It's 10-year delay or so in the response time. There is no. We have to do it. It's utterly immediate. It's super, super urgent. Christophe, maybe you can add to that.
Well, one thing I'd like to specify is that all the conclusions of the IPCC are based on the 4 main emission scenarios that they selected. And the least emission scenarios is called the 1.9, and means that a global net zero would be reached by, I think, shortly after 2050. But this is only in the realm of what IPCC has selected, and it is a reference, and that's why it is important. But there are other scenarios that have been tested in the bibliography. It's not written in stone. We could, and we'd all be better off if we do better than even the most optimistic scenario that is retained in the IPCC. It's a difficult question to answer when we should actually stop, because the most central point is this global net zero. And the Paris Agreement also have the so-called equality clause, meaning that countries that have the economic and technological possibility to do more should reach their net zero timeline sooner than other countries that simply can't or that need to spend another few emissions just to reach the Agenda 2030 goals at the same time, the SDGs.
We have an energy imbalance between the energy coming into planet Earth and the energy going out due to the increased greenhouse gases. And so therefore there's the same amount of heat coming or energy coming from the sun, but less energy is getting out from escaping out of space from the Earth, and hence energy is conserved in the system. And most of that energy, like more than 90%, is actually accumulated in the oceans. There's only one way for planet Earth to sort of sweat out energy, to lose energy, and that is by radiation, by heat radiation. And it does that not by the radiation of the oceans or things like that, but actually radiation from the atmosphere, the greenhouse gases in the atmosphere. And in order to get sort of the same balance again, the atmosphere needs to get warmer so that we can lose the same amount of energy that we actually receive. And as the atmosphere gets warmer, yeah, that is global warming. So that is one way of sort of solving it. But we're not in balance today when it comes to this sentence. And we're increasing the amount of greenhouse gases in the atmosphere, carbon dioxide and others. And in order to sort of level out, about 50% of our current emissions end up in the atmosphere, and the others are absorbed by oceans and the biosphere. And if we sort of, when we go below 50% of our emissions, then we could imagine that sort of the current level of carbon dioxide in the atmosphere would sort of level out, because then those 50 gigatons of carbon, so today we emit about 10 gigatons of carbon. If we only emitted about 5 gigatons of carbon, there would be an absorption in the ocean with acidification as a consequence still going on, and in the biosphere. But we need to get below today's, 415 down to some 350. So we urgently need to go at least beyond 50% of the emissions. And that's sort of the tipping point when we can actually hope for the amount of carbon dioxide in the atmosphere to decrease.
I can just continue on that point, because like what I've understood from the Global Carbon Project that I work with, like in order to stabilize emission or stabilize temperatures, we need to go to zero emissions. And this is very complicated based on lots of assumptions. But basically, as I understood, what they are saying is that when we go, like if we, immediately go to zero emissions now, or, very quickly go to zero emissions, there's still residual warming in the system, but it will be countered by the carbon dioxide taken up by our ecosystems. So this countering means that the temperatures would more or less stabilize. This is based, among other things, on an assumption that our ecosystems will keep on functioning and keep on drawing down carbon. If they don't do that as we predict them to, and if there are other worse feedback loops, like the methane being much worse, like permafrost being much worse than expected, then that assumption, this probably won't hold. But at least that's what I understood from the carbon experts, saying that we need to go down to 0 to stabilize temperatures.